Choosing between fixed bids and time and materials, also known as T&M pricing for residential remodeling jobs, depends on several factors. Let's explore these considerations to help determine the best approach for different scenarios. Firstly, job complexity is a key determinant. Fixed bids are generally more suitable for less complex projects where the scope of work is well defined. In these cases, the contractor can accurately estimate the time and materials required, minimizing the risk of unexpected issues. However, for complex projects with potential hidden issues, time and materials may be a better option. These projects often involve uncertainties that can significantly impact costs, making it difficult to provide an accurate fixed bid upfront. Secondly, risk tolerance plays a significant role. Fixed bids transfer more risk to the contractor. The contractor is responsible for completing the project within the agreed-upon price, regardless of any unforeseen challenges or cost increases. On the other hand, time and material shifts the risk to the client. The client pays for the actual time spent and materials used, which can result in higher costs if unexpected issues arise. If one is confident in their cost estimates and ability to mitigate unexpected issues, fixed bids may be more favorable. However, if the project is inherently risky or the scope is uncertain, time and materials may be a more prudent choice. Thirdly, client expectations must be taken into account. Some clients prefer fixed bids for the predictability of costs. They want to know the total cost of the project upfront and avoid any surprises. Other clients may be more comfortable with time and materials for its flexibility. They understand that the scope of work may change during the project and are willing to pay for the actual time and materials required. Understanding client preferences and expectations is crucial in selecting the appropriate pricing model. Market competition also influences the pricing model. The pricing model one chooses may depend on the practices and expectations in their local market. In some areas, fixed bids are the norm, while in others, time and materials is more common. Researching the local market and understanding what clients expect is essential for staying competitive. When should time and materials be used? Time and materials is appropriate for complex or unpredictable projects. When the scope of work is not fully defined or may change during the project, time and materials provides flexibility and allows for adjustments as needed. When there is potential for hidden issues that could significantly impact costs, time and materials protects the contractor from financial losses. When the client is willing to bear the risk of potential cost overruns, time and materials can be a viable option. When should fixed bids be used? Fixed bids are suitable for simple or straightforward projects. When the scope of work is well defined and unlikely to change, fixed bids provide cost certainty for the client. When one is confident in their cost estimates and ability to control costs, fixed bids can be profitable. When the client is seeking a guarantee of the final price, fixed bids are the preferred choice. Hybrid approaches are also possible. One such approach is a fixed bid for the core work and time and materials for any unforeseen issues. This allows the contractor to provide a fixed price for the main portion of the project while accounting for potential uncertainties. Another hybrid approach is a time and materials contract with a not-to-exceed price. This sets a limit on the total cost of the project, providing some cost control for the client while allowing for flexibility in the scope of work. A third hybrid approach is a fixed bid with a provision for change orders. This allows for adjustments to the price if the client requests changes to the scope of work. Regardless of the pricing model chosen, clear communication and transparency are crucial. Discuss the pros and cons of each option with clients and ensure they understand the implications. Provide detailed estimates and explain how costs are calculated. Keep clients informed of any changes or unexpected issues that may arise. Maintaining open communication and transparency builds trust and helps avoid disputes. In residential remodeling, several electrical factors contribute to project costs. These include wiring, devices, and panel upgrades. Wiring is a fundamental aspect of any electrical project. The type and amount of wiring required will depend on the scope of the project. Factors to consider include the gauge of the wire, the number of conductors, and the length of the runs. Different types of wiring are used for different applications. For example, non-metallic sheath cable, also known as NM cable or Romex, is commonly used for residential wiring. Armored cable, also known as AC cable or BX cable, is often used in commercial or industrial settings. Conduit, such as electrical metallic tubing, also known as EMT, or rigid metal conduit, also known as RMC, is used to protect wiring in exposed or hazardous locations. The cost of wiring will vary depending on the type, size, and quantity required. Devices such as receptacles, switches, and lighting fixtures are essential components of any electrical system. The type and number of devices required will depend on the needs of the project. Receptacles provide power for appliances and equipment. Switches control lighting and other devices. Lighting fixtures provide illumination. The cost of devices will vary depending on the type, quality, and features. Panel upgrades may be necessary to accommodate increased electrical loads. If the existing electrical panel is not large enough to handle the new circuits required for the remodeling project, it may need to be upgraded. Panel upgrades can be costly, as they often involve replacing the entire panel and associated wiring. However, they are essential for ensuring the safety and reliability of the electrical system. Several factors influence the cost of electrical work in residential remodeling. These include the scope of work, the complexity of the project, the materials used, and the labor rates. The scope of work is the most significant factor affecting the cost of electrical work. The more extensive the project, the more it will cost. A simple project, such as adding a new receptacle, will cost less than a complex project, such as rewiring an entire house. The complexity of the project also affects the cost. Complex projects, such as those involving intricate wiring or difficult access, will cost more than simple projects. The materials used also impact the cost. High-quality materials will cost more than low-quality materials. However, using high-quality materials can ensure the longevity and reliability of the electrical system. Labor rates vary depending on the location and the experience of the electrician. Electricians with more experience typically charge higher rates. However, they may also be more efficient and provide higher quality work. When estimating electrical costs, it is important to consider all of these factors. Get multiple bids from qualified electricians to ensure a fair price. Be sure to ask for a detailed breakdown of the costs, including materials, labor, and any other fees. The National Electrical Code, also known as NEC, is a set of standards for the safe installation of electrical wiring and equipment. It is important to follow the NEC when performing electrical work to ensure safety and prevent fires. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is updated every 3 years to reflect changes in technology and best practices. Familiarity with the NEC is essential for anyone performing electrical work. Some common electrical code requirements include the following. Firstly, all electrical work must be performed by a qualified electrician. Secondly, wiring must be installed in accordance with the NEC. Thirdly, overcurrent protection, such as circuit breakers or fuses, must be provided for all circuits. Fourthly, all electrical equipment must be properly grounded. Fifthly, ground fault circuit interrupter, also known as GFCI, protection must be provided in wet locations, such as bathrooms and kitchens. Ignoring these requirements can lead to dangerous situations. Several tools and equipment are essential for performing electrical work safely and efficiently. These include wire strippers, pliers, screwdrivers, voltage testers, and conduit benders. Wire strippers are used to remove insulation from wires without damaging the conductors. Pliers are used to grip, bend, and cut wires. Screwdrivers are used to tighten and loosen screws. Voltage testers are used to check for the presence of voltage. Conduit benders are used to bend conduit to the desired shape. In addition to these basic tools, there are also a number of specialized tools that can be helpful for certain electrical tasks. These include fish tapes, cable cutters, and knockout punches. Fish tapes are used to pull wires through conduit. Cable cutters are used to cut large cables. Knockout punches are used to create holes in electrical boxes and panels. Using the right tools for the job can make electrical work easier, faster, and safer. Electrical safety is paramount when working with electricity. Always follow safety precautions to prevent electric shock and other hazards. Firstly, always turn off the power before working on any electrical circuit. Use a voltage tester to verify that the power is off. Secondly, wear appropriate personal protective equipment, such as safety glasses and rubber gloves. Thirdly, never work in wet conditions. Fourthly, inspect tools and equipment for damage before use. Fifthly, never overload circuits. Sixthly, never tamper with electrical equipment. Seventhly, call a qualified electrician for any electrical work that one is not comfortable performing. Remember that electricity can be dangerous, so always take precautions to protect oneself and others. Let's review some specific examples of how fixed bids and time and materials pricing might apply to different residential remodeling scenarios. Scenario 1 involves replacing an existing light fixture with a new one. This is a relatively simple project with a well-defined scope of work. A fixed bid would be appropriate in this case. The electrician can estimate the time and materials required and provide a fixed price for the job. Scenario 2 involves adding a new receptacle to an existing circuit. This is also a relatively simple project, but there may be some uncertainty about the wiring behind the wall. A fixed bid could still be used, but the electrician may need to include a contingency in the price to account for potential unforeseen issues. Scenario 3 involves rewiring an entire kitchen. This is a complex project with a potentially undefined scope of work. Time and materials may be a better option in this case. The electrician can charge for the actual time spent and materials used, which allows for flexibility as the project progresses. Scenario 4 involves upgrading an electrical panel. This is a potentially complex project, depending on the age and condition of the existing panel. A fixed bid may be possible if the electrician can thoroughly inspect the existing panel and determine the scope of work. However, if there is uncertainty about the condition of the panel, time and materials may be a better option. Remember that the best pricing model will depend on the specific circumstances of the project. Consider the job complexity, risk tolerance, client expectations, and market competition when making your decision. Always communicate clearly with clients and ensure they understand the implications of each pricing model. Understanding voltage drop is essential for electrical installations, especially in residential remodeling projects. Voltage drop refers to the decrease in voltage that occurs along a conductor due to its impedance and the current flowing through it. Excessive voltage drop can cause various problems, including dimming lights, malfunctioning equipment, and overheating wires. The National Electrical Code, in Informational Note Number 2 to Section 210.19 AON, recommends that the voltage drop on branch circuits should not exceed 3% at the farthest receptacle, and the combined voltage drop on feeders and branch circuits should not exceed 5%. Several factors influence voltage drop, including the length of the conductor, the gauge of the conductor, the current flowing through the conductor, and the type of conductor material. The longer the conductor, the greater the voltage drop. The smaller the gauge of the conductor, the greater the voltage drop. The higher the current flowing through the conductor, the greater the voltage drop. Aluminum conductors have a higher resistance than copper conductors, resulting in greater voltage drop. To calculate voltage drop, one can use the following formula: voltage drop equals 2 times K times I times D divided by circular mils, where voltage drop is the voltage drop in volts, K is the direct current constant, which is 12.9 ohms circular mils per foot for copper and 21.2 ohms circular mils per foot for aluminum, I is the current in amps, D is the one-way distance in feet, and circular mils is the cross-sectional area of the conductor in circular mils. To minimize voltage drop, one can use larger gauge conductors, shorter conductor runs, and copper conductors. It is also important to properly size the conductors for the expected load. Using online voltage drop calculators can simplify the process of calculating voltage drop and selecting the appropriate conductor size. When performing electrical work, Always consider voltage drop to ensure the safe and reliable operation of electrical equipment. The ampacity of a conductor is the maximum amount of current in amps that a conductor can carry continuously without exceeding its temperature rating. The ampacity of a conductor is determined by several factors, including the size of the conductor, the type of insulation, the ambient temperature, and the number of conductors in a raceway or cable. The National Electrical Code provides tables that list the ampacity of different types of conductors under various conditions. Table 310.15b16 in the 2020 NEC, formerly Table 310.16 in earlier editions, is commonly used to determine the ampacity of conductors based on their insulation type and temperature rating. It is important to select conductors with sufficient ampacity for the expected load to prevent overheating and potential fire hazards. When conductors are installed in a raceway or cable with multiple current-carrying conductors, the ampacity must be derated to account for the increased heat generated by the conductors. The NEC provides derating factors in Table 310.15 cone. For example, if there are 4 to 6 current-carrying conductors in a raceway or cable, the ampacity must be derated to 80% of its original value. It is also important to consider the ambient temperature when determining the ampacity of conductors. If the ambient temperature is higher than the temperature rating of the conductor, the ampacity must be derated. The NEC provides correction factors for ambient temperatures in Table 310.15 burn. For example, if the ambient temperature is 95 degrees Fahrenheit, the ampacity of a conductor with a temperature rating of 75 degrees Celsius must be derated to 91% of its original value. When performing electrical work, always consult the NEC to determine the appropriate ampacity for conductors and apply any necessary derating or correction factors. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. Bonding connects all metal parts of an electrical system together, creating a low impedance path for fault current. The National Electrical Code requires that all electrical systems be properly grounded and bonded to protect against electric shock and fire hazards. The grounding electrode system typically consists of a grounding electrode conductor connected to a grounding electrode, such as a ground rod, a metal water pipe, or a concrete encased electrode, also known as a U for ground. The grounding electrode conductor must be sized according to Table 250.66 in the NEC. The bonding system typically consists of bonding jumpers connecting metal enclosures, raceways, and equipment together. Bonding jumpers must be sized according to Table 250.102 in the NEC. Ground fault circuit interrupters, also known as GFCIs, are devices that protect against electric shock by detecting ground faults and interrupting the circuit. The NEC requires GFCI protection in wet locations such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, also known as FCIs, are devices that protect against fires caused by arc faults. Arc faults are dangerous electrical faults that can occur when insulation breaks down or connections become loose. The NEC requires FCI protection for branch circuits that supply dwelling units. When performing electrical work, always ensure that the electrical system is properly grounded and bonded and the GFCI and FCI protection is provided where required. Short circuit current rating, also known as SCCR, is the maximum amount of short circuit current that an electrical component or system can safely withstand without failure. It is important to select electrical components and systems with an SCCR that is equal to or greater than the available short circuit current at the point of installation. The available short circuit current is the amount of current that would flow in a short circuit condition. It is determined by the impedance of the power source and the conductors. The SCCR of electrical components and systems is typically marked on the equipment. The NEC requires that electrical components and systems be selected and installed in accordance with their SCCR. If the available short circuit current exceeds the SCCR of the equipment could fail, potentially causing a fire or explosion. To determine the available short circuit current, one can perform a short circuit study. A short circuit study is an engineering analysis that calculates the magnitude of short circuit current at various points in an electrical system. The results of the short circuit study are used to select equipment with adequate SCCR. When performing electrical work, always consider the available short circuit current and select equipment with an appropriate SCCR. Electrical plans and permits are typically required for residential remodeling projects that involve electrical work. Electrical plans show the layout of the electrical system, including the location of wiring, devices, and equipment. They also provide information about the types of materials to be used and the methods of installation. Electrical permits are required by local jurisdictions to ensure that electrical work is performed safely and in accordance with the NEC. Obtaining electrical plans and permits can be a time-consuming process. However, it is essential for ensuring that the electrical work is done correctly and safely. To obtain electrical plans and permits, one must typically submit an application to the local building department. The application must include detailed electrical plans and specifications. The building department will review the plans and specifications to ensure that they comply with the NEC and local codes. Once the plans are approved, a permit will be issued. Electrical inspections are typically required after the electrical work is completed. The electrical inspector will inspect the work to ensure that it was performed in accordance with the approved plans and the NEC. If the work passes inspection, a certificate of occupancy will be issued. When performing electrical work, always check with the local building department to determine the requirements for electrical plans and permits.